All right, guys. Here's a couple of review videos coming out just as we are quickly approaching the end of our first unit, which is next week. I wanted to give you kind of a heads up on some of the questions that I've been asked and how do you tell the difference between the atomic number, atomic mass, the number of protons, neutrons, and electrons in an atom itself. So here are two different lithium periodic table of element squares that we have available. The first one is the one that we typically see on the periodic table of elements. We have the 3, the Li, which is the symbol for lithium, and then the 6.94. Sometimes you also see it written in this variation where the 6.94 is on top, the Li, the symbol, and then the 3 from here. Both of them are saying the same information. We just have to be able to decipher what that information is. The 3 on top of the first one is representing our atomic number, and our atomic number is what identifies our element. So lithium can only have an atomic number of 3. If it becomes a 4, if it falls back to a 2, we're now talking about a brand new element. The 6.94 is the atomic mass. And remember, the atomic mass is the number of protons and neutrons combined together, and they make up the mass of the atom itself. The electrons are too small to have any mass that's able to be calculated in there. So for this one, we take a look and we say, hey, Mr. Arnold, we got a 6.94. We can't have part of a proton. It's either got to be a whole or it's not available to us. The 6.94, remember, is an average of all of the naturally occurring isotopes that are out there. So sometimes we can have variations inside of the nucleus of our atom where lithium may have 4 neutrons, maybe it has 5, maybe it only has 3. And so this is an average number that we are working with from here. Again, same thing is going on over here. We have our atomic number, and we have our atomic mass. The only difference is it's now flip-flopped on top or on bottom. Really what you need to do is look at which one is the smallest. The smallest number on the periodic square is going to become our atomic number. The larger number, because it has protons and neutrons combined together, is going to be our atomic mass. So really, it's nothing different. It's just a different version of how to see it. But the numbers and the meanings are still there, whether it's the atomic number or atomic mass. How do we find our number of protons and our number of neutrons and our number of electrons inside of the periodic table? Well, remember, our atomic number identifies our element. So our atomic number is always equal to the number of protons. If you stumble across an atom and it has 3 protons, you know you're looking at some sort of variation of a lithium atom. The atomic mass, again, is calculating the total number of protons and neutrons. And so the atomic mass is always going to be equal to our atomic number, which is our number of protons, plus, again, the number of our neutrons. How does that help us out? Well, if we were trying to find the number of protons, we're going to just look at our atomic mass. We know that we have 3 protons. If I want to know the number of electrons, we know that protons are positively charged. So we are going to assume all atoms are neutral and balanced on the periodic table. So if I have 3 positive charges, I must also have 3 negative charges inside of our atom itself. So the atomic number not only equals the number of protons, but it also equals the number of electrons in a neutral balanced atom for ourselves. The number of neutrons is going to be figured out by taking our atomic mass and looking at the number of protons and neutrons combined together. So we said earlier you can't have just 0.94 of an element. You either have to have you have to have a whole or you don't have one at all. So we're going to round our atomic mass up to 7. 0.9 would round up to 7 there. And then we already know that we have 3 protons, and so we're just trying to solve for our number of neutrons, and that's just simple math. We subtract 3 on one side, whatever we do on the other side, we're going to subtract 3 there, right? So we have 4 neutrons inside of our atom right there. And again, neutrons are neutral. It doesn't affect the charge of the atom, whether it's positive or negative. It just helps make up the central mass of the atom itself. So that's how we can find the atomic number, the atomic mass, the number of protons, neutrons, and electrons in an atom.